Hello everyone, welcome to the Electron Flow Academy. So, our today's topic is power in the AC circuits. So, our today's topic, power in AC circuits. So, basically, the power in the AC circuits are divided in three parts. First part is known as the active power. So, alternatively, the word used for the active power is also real power, actual power, power, and watt full power. Also use full power and so on. So basically, if I talk about the DC circuit, so in a DC circuit, power supply to the DC load is simply the product of voltage across the load and current flowing through the load. Okay. So if I talk about the P of DC is equal to P into I. Okay, so because in the DC circuit there is no concept of the phase angle between current and the voltage. Okay, so in other words, there is no power factor in the DC circuit. But the situation in the sinusoidal or the AC circuits is more complex because of the phase difference between cause of the phase difference between voltage and current. Okay, so therefore, average value of the power or real power is equal to I cos theta. Okay, so is in fact supplied to the load. Okay. Further in the AC circuits, when the circuit is pure resistive, then the same formula is used for power as used in the DC. Okay. Basically, the formula is P equal to VI. So the real power formula, this is for DC, okay, and this is for single phase AC circuits. Okay, next, if I elaborate further this formula, then real power is also equal to the root 3 times of line voltage into line currents multiplied by cos theta. Okay, so this is for three phase AC circuits. Okay, and again, P is equal to 3 times of phase voltage in phase current times cos theta. Okay. We can also rewrite the active power is equal to the root of apparent power square minus the sorry reactive power square. Okay. Let me correct here. Minus reactive power square. Or real power is also equal to under root of VA square minus VAR square. Okay. So this is the basic concept of the active power. Okay. So next power which is known as the reactive power. Okay. So reactive power also known as useless power or watt less power. So basically the powers that continuously bounce back and fourth between source and load is known as the reactive power. Okay. Or we can say that the power merely absorbed and returned in load due to its reactive properties is referred to the reactive power. Okay. Basically, the unit of active or real power is watt. Okay. So here 1 watt is equal to 1 volt into 1 ampere. Okay. Whereas the reactive power represent that the energy is first stored and then released in form of magnetic field or electrostatic field in the case of inductor and capacitor. Okay, the case of inductor and capacitor. Okay, so the reactive power is given by Q. This is represented by Q. Okay, is equal to P times I sine theta. Okay, P times I sine theta. So here, which can be positive for inductive and negative for capacitive. Okay, positive for inductive load and negative for capacitive load. Okay, the unit of reactive power is volt ampere reactive. Okay, that is VAR. Okay, so where 1 VAR is equal to 1 volt into 1 ampere. Okay, so if I talk in more simple words, in inductor or capacitor, how much magnetic or electric field made by 1 ampere into 1 volt is called the unit of reactive power. Okay, formula for the reactive power is equal to P equal to VI. This is for DC circuits. Okay, and Q is equals to VI sin theta. Okay, or we can say that the reactive power is equal to under root of apparent power square minus active power square. Okay. Further, if I talk in terms of units, VAR is equal to under root of VA square minus P square. Okay. So this is the basic concept for the reactive power. The next power, which is known as the apparent power. Okay. So basically, the product of the voltage and current, if and only if the phase angle difference between the current and voltage is ignored. Okay, so the total power in the AC circuit, total power in an AC circuit, both dissipated and absorbed or returned is referred to as apparent power. Okay. So basically, the combination of the reactive power and the true power is called the apparent power. So in AC circuit, the product of the RMS voltage and the RMS current is called the apparent power. Okay, so this apparent power is denoted by capital S. Basically, capital S is equal to RMS value of voltage multiplied by RMS value of current. Okay, so when the circuit is pure resistive, then the apparent power is equal to the real or the true power. But in the case of the inductive or capacitive circuit, when reactances exist, then the apparent power is greater than the real or the true power. Okay, so basically, as is equal to Vi or under root of P square plus Q square. Okay, and if I talk in terms of the power triangle, if I talk in terms of power triangle, then this will look like this is our phase angle theta. Theta is phase angle. Okay. And this is our watt real power. P. This is your Q reactive power, which unit is VAR. This is the watt. This is actually the results, which is known as the apparent power S. Okay. Which unit is kVA. If I talk in terms of kilo, this is the power triangle. So this power triangle shows that greater the value of the theta in the circuit, the theta is basically the phase angle difference between V and I. So the greater the value of the theta in the circuit, there is the more reactive power is available in the cable. Less value of the theta will gives the less power of the reactive power. So if the theta is equal to 0, then P is equal to Vi or P is equal to S. In the case of the theta is equal to 0, the reactive power is also 0. Okay. So thank you very much for watching this video. Kindly like and subscribe our channel.